What does a database have to do with machine learning? Everything. Machine learning lets you do science fiction-like things with your data to produce information that will supercharge the productivity of your organization. Instead of struggling with the complexities of machine learning, RavenDB will manage all of it for you. You don't need a complicated pipeline or to integrate multiple systems. Once you have RavenDB with integrated machine learning, you can query on the new data you produce. That means utilizing classic RavenDB features like automatic indexing, full text search, and native MapReduce aggregations to perform analysis on massive amounts of information at eye-popping speeds. You can train your model to detect all sorts of interesting details, and the results are going to be transparent to the rest of your system. Today, RavenDB CEO Oren Aney shows you how to easily integrate tomorrow's technology into today's database to give you clear answers, sure to brighten the future of your organization. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi, everyone. I'm very happy that you're here with blah, 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 blah. Hi, everyone. I'm very happy that you're here with me. And it's interesting because we now have what is supposed to be a very hot topic. So instead of just giving you the details about, okay, this is how you can do machine learning with RavenDB, I wanted to give you the backstory, how it all came about. And it went roughly like this. You have the CEO, that's me, and the CEO keeps seeing machine learning everywhere. And the current status is that if you have machine learning, then you're good. Therefore, we should have machine learning. So I went to the team, and the team went like this. What? And let me give you the motivation. The motivation is very simple. Take any team, add machine learning, and people will throw money at you. I mean, that's how it works, right? There was, I think, a fruit company that changed their name to be a fruit company blockchain, and their stock went up because people are not really paying attention to stuff, probably because they're not using machine learning. So before we start, let's talk about how I understand what machine learning is. And I want to emphasize, I'm a database guy. So I've been doing that for 15 plus years now. So I feel quite comfortable at the database layer and how the database works and also all sorts of stuff like that. With machine learning, let's see how it goes. So machine learning goes like this. There is matrix multiplication, and that's about what I know. So I spent a lot of time thinking and researching and trying to figure out how things are going, and I figure things out. You take a turkey, you put it in an iron suit, the result is, ta-da, mechanical torque. And everyone knows that mechanical torque can do all sorts of really interesting, almost magical insight. I mean, they had a mechanical torque in the 1980s. Sorry, not 1980s, in the 1800s that could play chess and win, apparently. So this is how it works. You get a turkey in a mech suit, and that gives you machine learning because it looks like a machine. And apparently there's also a lot of GPUs involved. I'm not certain how that works. I assume there are idle moments, so they want to play stuff. But, you know, that's roughly it. So with that, the issue is how do I get turkey to into RavenDB? And apparently Halloween already went by this year, but that's the issues of scheduling things by the marketing people who don't understand that machine learning is actually all about turkeys. So let's see. Seriously, this is not about machine learning itself. This is about applying that inside the context of RavenDB. And while I'm not, let me put it this way. From my perspective, machine learning is roughly what I described. You have a magic wizard and you have a black box, you give it input, you give it output. Apparently, there are all sorts of interesting terms like neural network and convoluted neural networks and something like layering and apparently there is math, but you don't want to be too precise. You want to do it in floats. Whatever. I don't know that. I don't, and frankly speaking, I don't want to know that. So what I do want to know is how I can take the result of that and use that. So something really, really quite important. Machine learning is effectively a computer program, even if one that I cannot debug. And the Jigger rules still apply. So if you throw bad data into machine learning, then you get bad results out. In fact, in many machine learning scenarios, one of the problems was that the machine does too well. If you go and analyze certain details, for example, incarceration rates in the States, and you use that to predict who would be a criminal or who would be incarcerated in the future, you're probably going to see some trends that don't necessarily match up with what you expect. So again, garbage in, garbage out, or bias in and bias out, and sometimes they can be quite bad. In the same sense, when you're doing machine learning project, make sure that you're testing for three things. One, that your actual observations match the expected world. For example, if you test only on dogs, when cats come in, then the system has no way of knowing what that is. That wasn't in the training set. The second thing is that watch out for unexpected bias. I think that one of the common issues was with, oh, we can see that we don't have enough females in the high ranks of this company. Okay, that's a fact. If we train the machine learning to look at CVs based on our current workforce, we still have few females, few women in the company. Lastly, and most interestingly, you have to be aware of adversarial inputs. So if people know that you're using machine learning, they would give you really bad data intentionally because that would feed into the biases of your system. Or actually, it can cause all sorts of really interesting details later. We have a question from Max Karpov, and the question is, what type of machine learning algorithm do you support? And the answer is all of them, or none of them, depending on how you want to see that. So I think that I had enough intro and I gave you my spiel about machine learning and how I don't know anything about that. Let's go and talk about this more seriously. Machine learning is divided into two modes. You have the learning and the predicting. I'm not touching anything about the learning, predicting, all of that. All of this is done directly through some other means, magic. The issue here is that now you have a model, you want to throw something into that model and get the results back, and then you want to do stuff with them. And this is where RavenDB comes into play. So let's talk about something simple. I want to add some meaning to a free text that is right, but the machine doesn't understand that. So if I'm looking into here we have some reviews, and this is from the Amazon reviews dataset. And you can see here we have all sorts of books and musics and all sorts of other stuff like that. Here we have reviews. So let's assume that I want to understand whatever this is, a good review or a bad review. I could, of course, ask the user. And these sort of things are actually incredibly useful when you're training, not touching that. But I want to be able to look at this, and this may be some text that you get on comments or basically anything that you want to analyze, and I want to understand how it works. So what we're going to do we're going to review the text to discover whatever this is positive, negative, or neutral. Now, again, I have absolutely no idea how to use machine learning and how to train models and stuff like that. I'm stupid this way. So instead, I'm going to click here. And somewhere around here, I'm going to want to do text classifications. So apparently, you can do it using this program. And this is the model that you use. Perfect. But I want to do that in RavenDB. So let's go here. And now you can see that I have this thing from docs, and I want to index the sentiment from text classification of the body. And that's not something that you see. Probably you're not familiar with this class. This is because I just made it up. More to the point, here is this class. And you can see that this is done using a couple of features in RavenDB, additional sources and additional assemblies. And what we basically do, we integrate with Microsoft ML, and more specifically with a TensorFlow in this case. And we ask the engine to predict our results. Then we use the prediction to know whatever this is positive or negative input. And based on this, we can decide whatever this is positive, negative, or neutral. There is, in this case, I'm not going to go over the entire code, but you can see that I'm downloading this model. This is literally downloading this thing. Setting it up. By the way, I mentioned that adversarial input is stupid. So what this code does, it's basically classify text. And the way that it classifies text is using something that looks, where is that? This was a great show. So it now say, okay, let's tokenize that into terms. Let's assign, and that's effectively a vector. And we can say, okay, this vector has positive relations. And we run that over many different training scenarios. And now we have lots of vectors, and we know whatever they're good, negative, or positive. Now for the unknown input, what we're going to do, we're going to, again, create a vector and see where it's nearby. And this was the total layman explanation of how it works. It doesn't work like that, but it makes for a great sense to get the concept. And now we do, all of this are literally stuff that we're taking from here. I just massaged that a bit so you wouldn't see all of the scary stuff. And the end result is that I'm creating this prediction engine. And the rest of that is not really that interesting. Something that is important, creating the engine is expensive. I'm only doing that once on a per thread basis. And indexing RavenDB is always going to use a single element. Now, Max is asking whatever I'm doing batch prediction. And the answer is not. This is not going to do a batch operation. This is only applicable for a single document at a time. Why is that? Because this is being invoked on per document. Now, if you have multiple documents at the same time, that just works. We have a question from Katal, and does this work on RavenDB Cloud? And the answer is yes, it does. How it does it is with this fact. We are integrating with all of those details, blah, blah, blah. This is also why I'm using this method, because I explicitly want to, don't want to upload the model somewhere. I can just make it accessible to the database. The database will actively download that and then cache that locally, and that makes the deployment story in the cloud a lot simpler. Now, notice what this effectively does. What we are basically doing, we are shelling out to Microsoft ML, to ML.NET, and asking it to do something with a model. From that point on, everything is just the same as you would think it would be in RavenDB. All of the other operations are valid. We can go here and ask questions such as, give me all of the positive inputs. By the way, notice that, again, this is not really that useful because we have this, but again, I'm trying to go to the simplest mode of operation, to the thing that I can show in demo and stuff. If you actually understand how ML.NET or machine learning in general works, I'm going to assume that you can do better than that. And presumably you can ask questions such as, okay, give me whatever he's angry, or she's upset, the dog died, blah, 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 whatever. Text analysis and how much of an effect. Now, this is the simplest model. Just shell out and do something. But remember that when I said that I can do everything in RavenDB on top of this, I can also do this. And here I'm saying, okay, let's invoke, and this is the same thing as before. Let's invoke ML.NET in the indexing process of a MapReduce index. So now I have this sentiment analysis, and now I can ask questions such as, okay, order by, what is the most liked book? And apparently it's Harry Potter. And how about most disliked book? And that's Twilight. Okay. So the whole idea is that RavenDB gives you a platform to run those things. And once you have them, then it's just going to be part of your system. And it's applicable for all of the other stuff that you can do. Now, let's go here, and that's the demo. We just did that. Okay. Now, there are a couple of things that we have to take into account here. What happens when you update the model? So, again, RavenDB does absolutely nothing with the model itself. But what you want to be able to do, you want to be able to ask questions such as, okay, now that I have more data, I retrain the model, I want to do something with that. Either I want to run over all of the existing data and recompute the machine learning model to run new predictions, or I just want to apply that for new predictions. The easiest way to handle that is to just replace the model that you're working on without resetting the index, in which case only the new data would have this applied. And the way to handle that is effectively during the indexing process in here, you're providing some hook that would rebuild the engine when something interesting happens. Okay, so replacing the model, one way is just replace the model and keep reindexing. The other way is reset the index, in which case we are going to apply the new model to all of the data. Now, this is a nice example, but it's fairly simple and not really that fancy, let's call it this way. So let's do something slightly more interesting. And apparently there is the tiny YOLO model, and apparently there is the Opal neural network cactus or something, whatever this is, Onyx. Opal neural exchange. Okay. So basically, those are all sorts of interesting models that you can try to use. And I use something called YOLO because you only live once. Now, let's go and look at that. In this case, what we want to do picture analysis. So now I have basically doing object classifications. I'm getting the objects and transforming them, getting all of the data out. And this is again the standard object classification example that you can see here. Okay, I'm not seeing that, but it should be somewhere around here. Okay. I'm not sure where it went, but we leave it at that. Now, I'm loading the data, I'm finding all of the outputs, and then I basically can categorize it based on one of those details. Now, let's see how that works. And if you want, you can give me some possible matches from here. I'm going to go and do a query, image query, and try to do this live to see how that works. In the meantime, you can see here that I'm taking all of the object classifications and I'm effectively creating two things. I'm creating that as tags and I'm creating dynamic fields to be used for the indexing. Let's see why it matters. It matters because you can see I have car, cat, dog, blah, blah, blah. And then I have the tags. So I can see how, so I can ask questions as, give me all of the documents where they have an image that is reasonably similar to a person. So let's go into a query. Well, tags in person. That's good. But I can also ask this. And let's see if I have something else that car. Come on. Let's look at the images. That would help. So here we have one image, and this is of this dude. Another image, and dude and a doggy. And this is hopefully a cat. And whatever this is a car. Okay, let's search for a boat. And I think this looks like a boat. Yes. Okay, so now let's see what happened when I'm querying over a boat. Absolutely nothing. That's actually interesting. Let's see why not. You can see I'm asking, show me the raw results. And I think this is, let me check something. PNG or JPEG, that's okay. The last one, and this is actually the fourth. That would allow us to identify that. Now going back here. Okay, so this one apparently have absolutely nothing that we recognize. That's interesting. That's the risk of doing things. Oh, that's because there is no boat here. Oh, there is a boat, but apparently not the right boat. Let's try to find this boat. Okay. I love doing live demos, but sometimes they're risky. And still nothing. Okay, let's try something else from the list of approved known sources. Cow. cow seems like it should be easy thing to identify. Let's take this one. And if not, I'm going to call it a day and say that unfortunately the magic has failed. Yay, now we have a cow. The tags, okay. So you can see that everything is in the model. If the model doesn't understand what's going on, then you don't know what's happening. We have a question from Katal. Computer vision is a good example where the AI at the edge is preferable. Would it be correct in saying that RavenDB is more useful for data mining historic data, so get all of the data in the cloud first, and then worry about it, analyzing it later? Good question. So the question is, how are you actually going to apply that? So let's take something that is probably a very simple example, a parking lot. And in the parking lot, I have something like this. This is the entry to the parking lot. And I have entry and exit here. Now in here, I have cameras. And I can use them to do a whole bunch of things. I can say, okay, I can recognize the plate number on the car, and if you're already paid or you're or if you're a subscriber to this parking lot, then you can go in and out without doing anything. We had a project where we did that with a Raspberry Pi, and RavenDB would run on the Pi directly, and all of the computer vision stuff was done on the Pi. Now, the issue there was that sometimes you run into cases where you couldn't find the appropriate, you have an image, when you have the real world and you try to figure out what is the plate number, you don't get any. The scenario then was that we would keep the image and then sync it up to the cloud. Sometimes, basically, we had a 3-layer approach. One, try to process that locally. Not working locally, try to process that with the cloud, with machine vision on Azure, AWS, GCP, much better than what you can probably do at the appropriate budget on in here. The final thing is that if both of them failed and couldn't find something relevant, we would move them to a training collection later on. And then we would basically go over that and see, hey, is this something relevant? To be totally honest, we thought about using mechanical Turk integration at that point, but there was sufficient high quality, and the typical answer at most cases was, okay, instead of opening the gate automatically, you have to put in the paper that you already got. The failure mode was easy. So, but computer vision at the edge, yeah, you absolutely like to do that. The question is, whatever you would do that inside of RavenDB. Because if you want to get the input directly, and you typically do on the edge, you tend not want to, okay, let's throw it into RavenDB. RavenDB would process that using its own mechanism and then come back out. You tend to, I can do it directly. Okay, so going back here, you can see that we have good ways in which we can integrate with the system quite easily, in fact. Now, all of those features come from one common aspect of RavenDB, and this is the ability to run arbitrary code and also pull very easily directly from NuGet. So you have the full power of NuGet at your fingertips. Now, that means that you can do things like that, and user upload an image, we recognize that, we are now able to query that, and do all sorts of interesting things. In facial recognition, you can try to do mood analysis. and see, oh, I can see that the pictures of this person or those states, are they happy, are they sad, and all sort of other dystopian issues. But there is an issue. And the issue is quite simple. What happened next? And I don't know if you notice, but I stopped processing those things because when I'm processing them, this is what my CPU looks like, and I actually want to be able to talk to you without stuttering, well, without stuttering too much. So machine learning is expensive in terms of computation resources. It sometimes can be incredibly expensive. So you want to look into that and figure out whatever this makes sense to you. In many cases, if you have to do that on the rare cases or in small data sets, great. In this case, notice that I'm processing that over, I think, 14 million records. So that takes a while. That takes a long while. But at the same time, if I'm processing that at the rate of 100 per second, maybe that's okay for you. But what happens when it's not okay? I still want to use those benefits. I still want to be able to use the machine learning output. So what do you think I should do then? And the answer is obvious. Go and use the appropriate resource. In this case, apparently you're supposed to use a GPU, but I have absolutely no idea how to actually use GPUs for machine learning. Again, database guy, not machine learning guy. So let's talk about how we can do that instead. So this is the relevant design. We have RavenDB and documents inside and data inside of RavenDB. Then we have a subscription that is going to go and work with some of the cloud APIs. By the way, I'm giving you some examples of the cloud APIs, but you can also talk to an OpenCV instance, or you can deploy your own GPU optimized machines, whatever. Let's see how that works. We're going to run it on this data. And let me go here. I want to see how it works when we actually talk about boats. I have this tendency to second. Boat. Now let's add this image here. In a few seconds, we'll see how that works. So what I've defined a subscription. This subscription is defined quite simply. Go over all of the items, and as long as they haven't already been classified. Now, because Python is so prevalent in machine learning systems, I decided to use that. So we're going to connect to this database. We're going to use the classify item subscription, and we're going to call the process batch. And this is the relevant call. So we're using the recognition from AWS, the AWS Recognition API. And this is what we do. We are accepting a batch of documents. For each one of them, we're seeing if it already has some existing tags. And this is basically just making sure that the bookkeeping is there. And now we're going to run over all of the attachments. For each one of them, we're going to get the raw results, create some recognition image, and then send it to Amazon. And let's clear it. And once we're done with everything, save changes and we're good. I actually want to backstock spell batch. I want to force it to run on smaller batches. So let's see how that works. I'm now running this. And what happens now is that it's starting to process for this particular document. So let's go to this document. And this is how it works. And now it went to AWS and asked it, hey, what does this look like? And now we have those answer. Apparently the beige cat. And if you compare these items to this, I can't say that this is far on. Pet, cat, animal, I don't know what this is. This is an interesting term. Okay, a type of a cat. Now this makes sense. And now if we go to this guy, apparently there is a human here. Oh yeah, there is a person here. I never even noticed. And this looks really good. Now, can I query on that? The answer is yes, I can. Here we go. So that gives us a lot of flexibility. That also means that I can use any any algorithm that I want. I can do GPU optimizations, all of the usual things that you basically want to have. That's the point. It's important to understand that now Raven will also monitor things. Now, let's say that I'm going to say dragon. Here we go. I wonder what this would do. So I'm adding a dragon, and you would expect that this would update, but this would not. And this is a very important consideration. You can see here that I'm setting the classify to true. Why am I doing that? Well, at the end of this batch process, I'm going to cause save changes. And all of my changes are going to be saved. Well, what's the problem? The problem is that I have a subscription on this. If I didn't have this, every time that I save the item, I would get it back because it changed. So in order for it to make sense, I have to go here and say false. And for fun, let's remove some of the tags. And now let's see what's going on. Now I'm going to have to merge tags from multiple such things. But I notice that this takes time. This takes time. I have to load the images, send it to AWS. The image recognition itself takes some time. So that is an interesting behavior. But in the end, here's a dragon. And that's the sort of thing that you can pull together in a very short amount of time, especially if you don't bother trying to understand that and just use that as a black box, which I think one of the major benefit of the cloud is just this ability to think about those as a cloud box, but you're still able to integrate that directly into your system. And Katal, you asked earlier about what happened with edge integration. So let's consider the case that we have here. Here we have the edge, and here we have the cloud. I'm going to be able to do some data here. And I already have a way to sync data to the cloud. In here, I can check if this wasn't done by the edge already. I can compute whatever we have here, and then it gets synced all the way back. Notice that in this case, RavenDB is used as the platform and the communication mechanism, and you have an application here, an application here that does the additional policy and behavior that you don't have otherwise. And now this is the time for questions. Unfortunately, I'm not going to be able to talk too much about how this works, but anything about utilizing that or in general about what you can do with RavenDB once you have that information, we're very happy to answer. And of course, as a reminder, you can go here to the cloud and get a free instance directly and start using RavenDB immediately. And all of those things that I've just shown, including machine learning integration, those sort of things are available to you directly. As long as we're speaking about this, here is another feature that you can use. You can use RavenDB, and this is something that if you're using legal documents or CMS, CRM, that's probably very useful. We're able to write this sort of index. Give me all of the attachments that are docx or Word or Excel. And now we have integration to get the text back. And we're using that again using OpenXML through NuGet. Now here is the code. Go over, and this is somewhat complex because Excel use something called shell strings. So let's look at this thing. Give me all of the paragraphs and just run with that. That's easy, that's simple. And that's the sort of thing that can make your application, I think. Because, you throw a Word document into the system, and it's now not just something opaque or something that you have to write a lot of code to work with. This is something that you can now start searching and processing and doing the whole thing yourself, including things such as, I can now understand do text analysis on the data, MapReduce, full text search, all of those sort of things. Okay, I think there are no more questions. Max is saying great demo, and thank you very much for that. I will be very happy to see you next time. Bye-bye.